Okay, so we have a couple more logarithm equations to solve. Okay, look at part E. Log base 16 of x plus log base 4 of x plus log base 2 of x equals 7. Now, you won't be too daunted by the fact that these logs have different bases because you now know that you can use the change of base formula to change them all into log base 2. Again, I suggest that you change all the bases into the smallest base present. So the log base 16 of x by the change of base formula equals the log base 2 of x over the log base 2 of 16. The log base 4 of x equals the log base 2 of x over the log base 2 of 4. And finally, the log base 2 of x we'll keep because that's what we want. Okay, now the log base 2 of 16 is 4 because 16 equals 2 to the power 4. So we can simplify this now as 1/4 log base 2 of x. Similarly, the log base 2 of 4 is the log base 2 of 2 squared, which is 2. So we have the 2 in the denominator. Dividing by 2 is same as multiplying by 1/2. So here we have plus 1/2 log base 2 of x and 1 log base 2 of x is here. So this is equal to 7. So totally I have 1/4 plus 1/2 plus 1 log base 2 of x's. So that is a total of 7/4 log base 2 of x, which is equal to 7. Okay, I need to take the power up. So when I do this, oh, sorry, actually, I think it'll be easier in this situation. We don't have to do all that. It'll be easier to just multiply both sides by 4/7. So that way the 4/7 times 7/4 is equal to 1. And we directly solve for the log base 2 of x equals 4. And from there, I know that I can get rid of the log by taking 2 to the power on both sides. So I find out that x equals 2 to the 4th, which is 16. Just check and see. It's positive, so it's allowed to be plugged in. It's a real answer, not a fake answer. Okay, so now we know how to deal with different bases. This problem has a base of 1/3, but we won't let that bother us. And at least we don't have to do change of base formula because we have the log base 1/3 of x squared plus x minus the log base 1/3 of x squared minus x equal to -1. So they're both the same base. We just need to bring them together into one log. We use, again, the fact that subtraction becomes division. So I have the log base 1/3 of x squared plus x over x squared minus x equal to -1. Okay, so I apply the inverse function of the log and I take 1/3 and raise it to the power both sides so as to cancel the log. On the left side, I obtain x squared plus x over x squared minus x, and on the right side, I obtain 1/3 to the -1 power, which is 1/3, which is the reciprocal of 1/3, which is 3. So I have to solve this equation for x. I can factor these, so that is x times x plus 1 over x times x minus 1. So at least I can get rid of one of the x's. So I just have to solve x plus 1 over x minus 1 equals 3. I'm going to multiply both sides by x minus 1 to get rid of it on the denominator. So that way I have x plus 1 equals, I have to distribute the 3x minus 3. Now it's just a linear equation. So I'm going to put all the x's on one side and put all the numbers to the other side by doing these operations. When I do that, then I get 2x equals 4. And so I can just divide both sides by 2, and I get x equals 2 for the answer. And then I can go back and check and make sure. So 2 squared plus 2 is positive, and 2 squared minus 2, that'd be 4 minus 2, is still positive. So it checks out.